All right, welcome to this explainer. Okay, mastering the exact differences between the World Wide Web and the Internet is absolutely 100% essential for your Cambridge Computer Science AS and A level. We're specifically targeting syllabus 9618 today, but honestly, this is highly relevant if you're taking 0417, 0478, 0983, 0984, or 2210. This topic shows up in almost every single examination series. But look, today we are definitely not just going to sit here reading textbook definitions. No way. We're adopting a mindset I call the weightlifter strategy. Think about it. Maximum effort in short, explosive bursts. High-mark questions require that exact same explosive power and immense precision. We're going to get right into the minds of the principal examiners to see exactly what they're demanding. We'll analyze real question structures, tear apart flawed answers, and rebuild them using high-level frameworks. By the time we finish this explainer, you won't just know the theory, you'll have a tactical, step-by-step blueprint to extract every single mark available. So let's get ready to level up.
Okay, let's dive into this. Why do so many candidates consistently drop marks on WWW versus Internet questions when they actually know the raw facts? Well, let's picture two typical students. First up, we've got Alex. Now, Alex has literally memorized the entire textbook. When a question asks to distinguish between the two, Alex confidently writes, "The Internet is a global network of interconnected networks. The World Wide Web is a collection of multimedia web pages accessed over the Internet." Boom, done, right? Actually, wrong. Alex just lost 4 out of 6 available marks. Why? Because there's zero analysis. Then, on the flip side, we have Sam. Sam definitely knows the concepts, but completely rushes under exam pressure, entirely missing the command words in the prompt. Sam goes off describing HTTP and IP addresses, but doesn't actually evaluate or compare as the question explicitly demanded. You see, both of these students fall flat, but not because they don't know their stuff. They fail because they lack analytical depth and structural discipline. And let me tell you, the examiner's red pen is totally unforgiving.
So, to fix this, we're going to use the examiner's playbook. Here is our roadmap for today. Number 1, core principles. Number 2, technical methodology. Number 3, evaluating algorithms. And finally, number 4, escaping examiner traps.
All right, jumping right into Section 1, Core Principles, where we focus on moving way beyond just reciting raw facts. Now, you have to understand that academic benchmarks for Cambridge 9618 absolutely require logical, structured reasoning. The whole conceptual framework of the exam draws on systematic analysis. This means the grading heavily prioritizes analytical depth over superficial breadth. You literally cannot just dump a list of facts about what the Internet is and what the WWW is onto the page. You have to explain the causal relationship between them. Superficial breadth looks kind of like this. The Internet uses cables, the WWW uses browsers. Seriously, that barely scrapes a minimum mark. But analytical depth? That looks more like this. The Internet provides the packet-switched network infrastructure utilizing IP addresses for routing. Conversely, the WWW is an application-level service relying on the Internet's transport layer to resolve URLs to IP addresses via DNS, enabling the retrieval of HTML resources. Do you see the huge difference there? That second answer uses authentic computer science terminology. It sets up the Internet as the physical hardware infrastructure and the World Wide Web as the software abstraction layer sitting on top. It perfectly executes the PEEL framework: point, evidence, explanation, link. It makes a point, gives evidence of protocols, explains the relationship, and links it back to the question. That is exactly how top-tier students engineer an argument.
And you don't just have to take my word for it. Listen to this direct quote from the Cambridge Principal Examiner Report. Candidates referencing cross-topic connections achieve significantly higher marks. The theoretical architecture of the WWW and the Internet doesn't just exist in some isolated vacuum. It rests on integration with other syllabus areas. Think about it. You can't fully explain the World Wide Web without at least briefly touching upon client-server models or encryption protocols like SSL and TLS, or even the algorithmic efficiency of search engines crawling the web. When you tackle a long-form question, connecting the network architecture to data security or routing algorithms immediately signals to the examiner that you are a high-level candidate. It shows you're seeing the whole matrix, not just isolated lines of code.
Moving on to Section 2, Technical Methodology, and specifically the method mark strategy. But hey, before we break down this incredibly important sequence, I want to make sure you're equipped for every single topic. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get into the methodology.
So, in Cambridge exams, marks are very frequently awarded for the process itself, the procedural framework. This right here is the exact standardized sequence you must use to tackle questions. Step 1. Deconstruct the question. Are they asking you to identify, describe, explain, or evaluate? Look, if the command word is evaluate and you merely describe, your maximum mark is capped right out of the gate. Step 2. Extract relevant data. If they give you a scenario about a local company setting up an intranet versus using the global internet, you've got to pull out those specific constraints. Step 3. Select your analytical framework. Are you comparing protocols, hardware versus software? Step 4. Execute with clear notation. Use structured bullet points or logical paragraphs based on that Peel structure we talked about. And Step 5. Present with correct terminology. Never ever say web address when you actually mean Uniform Resource Locator or URL. Never say data pieces when you mean data packets. Remember this, terminology is the literal currency of Cambridge exams.
All right, let's shift gears into Section 3, Evaluating Algorithms, focusing on efficiency and performance.
Now you might be wondering, wait, why are we talking about algorithms in a networking topic? Well, it's because practical application requires algorithmic thinking. Whether it's the step-by-step decomposition of how a DNS server actually resolves a domain name into an IP address, or how a writer uses Dijkstra's algorithm to find the absolute shortest path for a data packet to travel across the globe. Algorithm quality is evaluated by 3 main things. First, time complexity. How long does it take for a routing algorithm to calculate a path as the network scales up? Second, space complexity. How much memory is required to store all those massive routing tables? And third, which is absolutely crucial, edge cases and performance effects. Like what happens to the entire network if a primary transatlantic cable suddenly goes offline? How does the algorithm dynamically reroute that traffic? Understanding these factors allows you to make really justified recommendations. If an exam asks you to compare 2 approaches to data transmission, bringing in time and space complexity will instantly, and I mean instantly, elevate your answer above the average candidate.
And this brilliantly illustrates the exact timeline you need to follow when you're under pressure. Problem solving uses a very strict deconstruct, solve, evaluate timeline. Let's imagine you have a 5-mark question, which means you have roughly 5 minutes to answer. Minute 1, identify the given information. What specific network scenario are they providing? Minute 2, break it into logical steps. Identify the difference between the underlying internet transport and the www application layer in this specific context. Minute 3, solve systematically. Write out your crisp Peel paragraphs. Minute 4, check for reasonableness. Did you actually answer the prompt, or did you accidentally go off on a massive tangent about HTML tags? And finally, Minute 5, make your justified recommendations or conclusions. This tight, explosive 5-minute drill is exactly how the weightlifter strategy works. It's maximum power, perfect form, and absolutely no wasted movement.
Stop scrolling. I need your full attention for just a second. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy explainers.
Awesome. Now let's step into the absolute most critical part of this explainer. Section 4, Escaping Examiner Traps. We're going to do a quick interactive workshop right now, based on the top errors pulled directly from Cambridge Principal Examiner reports.
Across thousands and thousands of examination scripts, examiners have consistently highlighted exactly 3 massive, catastrophic mistakes regarding the www and the internet. Imagine you're handed a complex network chart right now. Can you extract the chord trend within 60 seconds? Data interpretation is critical. You have to extract from binary representations, perform calculations, and draw evidence-based conclusions. So let's break down the 3 specific writing traps where candidates just hemorrhage marks. And we'll do a quick find the flaw exercise as we go. Because if you can eliminate these 3 flaws from your exam technique, your grade boundary is practically guaranteed to shoot upwards.
Okay, mistake number 1. Answers are way too vague, totally missing specific technical details. For example, a student writes, "Data is sent over the internet securely." Let's find the flaw. Well, it's entirely vague. A green checkmark, top-tier answer would say, "Data packets are transmitted over the internet utilizing TLS encryption protocols to ensure data integrity and confidentiality." See the difference? Mistake number 2, forgetting to check boundary conditions and edge cases. When you're doing algorithmic thinking and network design, you have to ask what happens when inputs are 0 or at their absolute maximums. What happens during a massive DDoS attack when server capacity is completely exceeded? You must address these extremes. And mistake number 3, answers are not specific to the question context. If the exam scenario is about a local hospital's internal web portal and you start giving generic answers about global e-commerce, you are going to score a 0 for context. You have to mold your knowledge to the specific shape of the prompt every single time.
So the crucial point here is summarized perfectly by this examiner alert. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Let's do a quick 30-second speed writing challenge mentally. The prompt is, explain one advantage of utilizing the www over a proprietary WAN for a startup business. If you just rush and write, the www is global and easy to use, you get absolutely nothing. But if you apply the Peel framework and the examiner's advice, you'd write, one advantage for the startup is immediate global reach. That's your point. By utilizing standard WW protocols like HTTP on top of existing internet infrastructure, there's your evidence. The startup avoids the massive capital expenditure of laying proprietary WAN cables or leasing dedicated lines. That's your explanation. This allows the startup to instantly deploy their web services to any customer with an internet connection, drastically lowering barriers to market entry, and that is your link. That right there is a flawless, context-driven paragraph.
We are now entering the final phase, the exam mastery blueprint. This is your final checklist, synthesizing everything we've talked about into one cohesive system. We've taken the raw theory of the internet versus the World Wide Web, we've decoded the command words, applied the Peel framework, and implemented the time management matrix.
So I want you to picture a progress bar filling all the way up to 100% mark potential as you lock these 5 steps into your memory. Step 1. Identify key elements of the scenario. Step 2. Apply relevant principles. Ask yourself, is this about hardware infrastructure or software services? Step 3. Execute your analysis using algorithmic thinking, making sure to evaluate time, space, and those tricky edge cases. Step 4. Verify your results strictly against the command words. And Step 5. Present appropriately using absolutely impeccable computer science terminology. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I really want to leave you with this final, provocative thought. When you sit down for that exam, will your next answer just be a generic guess, secretly hoping the examiner is feeling generous that day? Or will it be a precise, context-driven method that practically guarantees top marks? Look, the choice is entirely yours. You now have the weightlifter strategy. You have the full blueprint. Drop a comment below with your target grade for computer science and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here. Keep pushing, keep analyzing, and I'll see you in the next explainer.